body, you got it? So I'm only calculating the moment of inertia of each one of these sections around its own body. But the goal, the question is asking us to find the moment of inertia of this whole thing about the center. So what do we need to do? Does this center go through the center? No. Does the center of this composite body go through the center? No. Does it go through the center? Does it go through the center? No. Does it go through the center? No. So what do we need? What's the next step? Well, what should the next column be? The parallel axis theorem. So now we are finding the moment of inertia about, do you see the difference between, and these might be kind of confusing. Here we're finding the moment of inertia about the center of each, maybe we should put this here, huh? Because this represents the centroid of each of those members. What do you think? And then this represents the main of the whole body. So it's going to be, I'm going to copy these numbers off. 1.146 times 10 to the negative 5 plus 3.56 times 10 to the negative 4. Or actually, maybe we should have just made this column the extra part. What do you think? Should we have made this column, that next column, just this, and then we add them together? Let's do that. I think that's better. This is different than what you see in your paper. So this is going to be, this is going to be y bar squared times the area. And y bar squared is also meters to the fourth. So now, we're looking at here, where its centroid is right here. What's the difference? What's the y bar here going to be different? 0.18 minus 0.18 minus 0.025, not right? Squared, do you agree?
Yeah.
What's the difference here? This is my y bar. The centroid of this is up 0.25, right? And this is up 0.18, so I said 0.18 minus 0.025. Squared times what's the area? 0.55. 0.055. And then this one is 0.18 minus, now we're looking at the triangles. Where's the centroid of the triangle? 1/3 of 0.4, right? So it's 0.18 minus, maybe we should have had a y bar column, huh? What's the y bar in your column? For section 1, 2, 3, 4. Let's go back and say the section is here in the y bar. What was the y bar for 1? 0.025. Next one?
0.13.
What? Paul?
Put 183, you're saying that's where the centroid is from the base of that left triangle straight up.
Right, so we're measuring everything from here.
Ah,
The centroid is being measured from here. And if you look on the other table, we have it here.
yeah, I
Here's
got
the
183,
location.
I got it.
Okay? So now it's going to be 0.18 minus 0.183 squared times 0.04. Everybody see what I'm doing? 0.18 minus 0.25 squared, 0.01812 rather. And then this one's going to be the same as that one. I think this is better, making a column that has y bar area on it. Elliot, could you tell me what the last I do using the parallel axis theorem, which states I take the centroid in the body and I add to it y bar squared times area. Could you tell me what the value turns out to be for one, section one?
1.33. 3.
1.33?
Others
3 threes? Okay. And then,
3. Times 10 to negative 3.
okay. Next one?
3.56 times 10 to negative 2.9.
1.9?
Yeah. Times 10 to negative 3.
Okay.
3.56 times 10 to negative 4.
Okay. And then we total it up. What's the total? What's the sum?
4.23.
4.33
23.
times,
10 to negative 3.
and the units are?
Meters.